thank you for introducing me. Yeah, I'm going to be talking about visualizing complex networks, and this kind of was inspired from some research project that I'm doing at the moment. So what I'll be talking about is how I took a particular complex network, which is of an intertidal mudflat in New Zealand, and it's from a data paper, and I'll talk about how I went about making it a visual aspect. So first of all, there are many kind of instances where complex networks need to be visualized, and the main problems that arise are from the size of the networks. They might have thousands, even millions of nodes and links, and that makes it quite difficult to draw conclusions from them if you're just going to put it in two-dimensional space. So this particular food web I'm working with consists of 118 nodes and 1,924 links. So it's not ginormous, but it's pretty big. And if you were going to visualize this just by randomly distributing the nodes in Euclidean space and putting the links wherever they exist, it would look like this. So a network like this, or a food web like this, is very difficult to gain any useful ecological conclusions from. And so clearly a better method of visualizing the network is needed. So in the talk, I will mainly be discussing two things. First of all, I'll present existing solutions to these sorts of problems, ranging from software and packages to theoretical strategies. And then I will talk about what I did with this particular food network to gain a meaningful visualization. So what have other people done? An article by Michael Pocock et al. Neatly summarizes all the different approaches that you can take when visualizing a network and what the priorities of those approaches are. So we need to strike a balance between information context and appeal, aesthetic appeal. So what we're aiming for is as high as possible of an information context while still maintaining high aesthetic appeal. And this is quite a challenging balance to strike, but somewhere kind of in the ideal section is where we're trying to aim for. So there are a few different methods of visualization that were presented in the network, in the article. So these are the different methods, and looking at each of them one by one, you can kind of decide what the aesthetic appeal is versus the information context. So the edge list, which just lists all of the nodes and the links, is probably the one with the highest information context, but the least aesthetic appeal. And if you look at maybe the chord, that would have much higher aesthetic appeal, but it's also hard to draw any kind of conclusion from. So this is how I went into creating my own visualization. I wanted to aim for the greatest aesthetics at the same time whilst maintaining the information context. So in my research, I found this software called Food Web Designer. And in order to use it, I need to have 3 different trophic levels of the food web. But there were 2 issues with that. First of all, the data was not separated into trophic levels. It was just a network. And second of all, there were far too many nodes and links, which is one of the main problems with these large complex networks. So to fix those 2 problems, first of all, I figured out an algorithm to create those trophic levels. So first of all, I considered all of the nodes at the base level, i.e. the organisms which don't consume any other organisms, and then found the second level, which consisted of organisms which consume the first level, and so on and so forth. And to deal with the issue of too many links and too many nodes, I kind of just halved the nodes by only looking at the food chain. So this is what the result is. Now, this hierarchical structure is much easier to interpret than the first visualization that I showed. So clearly we can already see just from the first attempt of creating some sort of structure, the aesthetic appeal has gone up significantly, and also has the information context, because now useful conclusions can be drawn from this. But this is still not good enough. So let's just kind of look at it in a bit more detail. If you compare this to the metadata provided for the nodes, I found certain categories that each of the trophic levels were separated by. So the highest level, highest species, ended up being mostly macroparasites, interestingly enough. And the second level, as you can see, trophically transmitted parasites and parasitic castrators. What really interested me is, why is level 1 mostly predators when one would expect the highest levels to be predators? So I tried a slightly more sophisticated algorithm in order to calculate the trophic levels, which comes from an R package called Cheddar. So this resulted in 6 trophic levels rather than the initial 4, and it looked like this. So now I think we can kind of see a lot more patterns and a lot more ecologically meaningful conclusions that can be drawn from this diagram. And then there was the issue of size, which I mentioned earlier. So by its nature, this food web is very large, but if it could be separated into smaller sections, then the visualization would be simplified. Now, I'm aware that I'm probably running over, so I'm just going to skip over to the visualization. Here we go. So separating it into smaller sections, again, increases that aesthetic appeal, which also increases the information context, making it easier to draw conclusions. I'll quickly summarize the next steps for this. So what I'd like to do is kind of incorporate some sort of 3D visualization to deal with the remaining links. And yeah, that is everything. Thank you very much.